Okay, business algebra, we've talked about adding, subtracting, and multiplying matrices by a scalar. So let's talk about multiplying matrices by each other. Before we can do that, we have to talk about how multiplication works for a matrix times another matrix. Okay, so this is a 1 by 2 matrix because it has 1 row and 2 columns. This is a 2 by 1 matrix, it has 2 rows and 1 column. How multiplying a row by a column matrix is you multiply the piece, like the ordered numbers, 1 times 2, 3 times 1, and you add them together. So 1 times 2 is 2, 3 times 1 is 3, 2 plus 3 is 5. Now, because there's only 1 row and 1 column, your answer is just one number. It would really just be a matrix with just 5 in it. But how does this work generally if the matrix isn't just a row or a column? Generally speaking, you can only multiply a matrix if the number of columns in the first one is equal to the number of rows in the second one. Basically, so there's the same number of terms as I go from left to right here as I go from up to down in the second one. So basically that means the numbers on the inside have to be the same number in order for it to work. Now your resulting matrix will be a different size. It'll be the size of the outer numbers, m by k result. So if you have a 3 by 2 matrix, this is at the bottom of page 1, it says, can you multiply a 3 by 5 matrix by a 3 by 5 by a 5 by 7, for example. It's 2 by 3 and 3 by 5 at the bottom, but this is going to work fine. As long as these two numbers match, yes, you can multiply. And the answer will always be the size of the outside numbers. So the answer would be a 3 by 7 matrix. So that's how multiplying matrices work, but let's see what it looks like in action on page 2. So on page 2, we'll do number 1A and B. Now 1A is negative 3, 4, 1, 5, 0, 4 by negative 6, 4, 2, 3, 3, negative 2. So the first thing you always have to ask yourself is can these be multiplied? Here I've got 1, 2, 2 rows by 1, 2, 3, 3 columns. Here I've got 3 rows by 2 columns. Do the inside numbers match? Yes, so we can multiply. The outside numbers are what I'm going to expect my results to be. So a 2 by 2 is my answer, so I know it should be about a square. So let's go through the process of actually multiplying it. To find the top left term, which is in the first column and the first row, I need to take the first column times the first row times the first column, because that's the row and column. So let's do the piecewise terms. Negative 3 times negative 6 plus 4 times 2 plus 1 times 3. That's 18 plus 8 plus 3 should be 29. So that means my top left term is 29. So the question is, how do you get the other 3? Well, there are more than one row and column in each of these matrices. The next term up here would be row 1, column 2. So I need to multiply row 1 by column 2. Same strategy, first term times first term, second times second, and so forth. So we've got negative 3 times 4 plus, looks like 4 times 3, plus 1 times negative 2. So that's negative 12 plus 12 minus 2. So those two make 0. So this is negative 2 in total. Now to get the second row, first column, I'm going to multiply the second row by the first column. So we've got 5 times negative 6 plus 0 times 2 plus 4 times 3. So that's negative 30 plus 0 plus 12, which is negative 18. And for second row, second column, I'm going to multiply second row by second column. 5 times 4 plus 0 times 3 plus 4 times negative 2. That's 20 minus 8, which is 12. So this allows me to do this multiplication, and I get the answer. It's a matrix 29, negative 2, negative 18, 12. That's a 2 by 2. So it's a relatively long arithmetic process. As you can imagine, the matrices can get even bigger than that, but it's not so bad. Now let's look at 1b. It says to multiply 1, 0, negative 1, 3, 1, 4 by 1, 7, 3, 2. So again, the first question you always ask yourself is, can I multiply these two together based on size? Okay, so this is a 2 rows by 3 columns. This is a 2 by 2. Do the insides match? No. That means I'm done right here. Cannot be multiplied. Why? Because let's talk about how this process would work. If I tried to multiply the first row by the first column, I'd have 1 times 1 plus 0 times 3 plus negative 1 times, there's nothing to multiply negative 1 by because it doesn't have the same number of terms, so it simply can't be done. Now, going to page 3, number 2, something interesting happens. It wants you to multiply two matrices together in 2 ways. And we'll start each of the problems. It says A is 1, negative 4, 3, 2. B is negative 2, 4, 5, 3. So if I do A times B, it's going to be a 2 by 2 because they're both 2 by 2s. 1 times negative 2 is negative 2. Plus negative 4 times 5. That would be negative 2 plus negative 20, which is negative 22. That's my top left term. However, notice if I do BA, that would be the first row of B times the first column of A. That would be negative 2 times 1 plus 4 times 3. It's negative 2 plus 12, which is 10. The first term of BA is 10. Now you can already tell we're not even done with this yet. What do you notice about these two? If I go AB and BA, they're actually not the same. So unlike our normal system where we add or multiply, 3 times 4, 4 times 3 are the same. 5 plus 3, 3 plus 5 are the same. For matrix multiplication, they will not necessarily be the same. Now, just like our normal math system, we have identities. The additive identity, so that's the number you can add to something without changing it, is 0 because any number plus 0 is itself. Similarly, for multiplying, there is a number we can multiply by anything and it will stay the same. That is 1. For that reason, the identity matrix for adding would be all zeros, because if you added a bunch of zeros to everything, it would be the same. But for multiplication, it's not. So the multiplication identity is the matrix with a bunch of 1s in the diagonals and the rest zeros. And we'll talk about that a little more as we use this to find inverses or show things are inverses, which we'll use our row operations, which was the last thing we did in class before we went online, which I'm sure you're thrilled about. And then we'll find matrices and their inverses in the second video for the lessons today.